So now coming to the JK flip-flop. So this is the program. So JK flip-flop is a widely used sequential logic circuit that can store one bit of information. It is a refinement of the ESR, that is set reset flip-flop, designed to eliminate the problem of indeterminate states that can occur within the SR flip-flops when both inputs are I. The JK flip-flop has input J, K, a clock input, and typically Q and Q dash, which is the inverted output. So this is the circuit, that is logical circuit of JK flip-flop. If the clock, that is J, control setting the output to high, and K is control resetting the output to low, and clock, the flip-flop only changes state on a triggering edge of the clock signal, and Q is the main output, and that is Q dash, it is the complementary output or the inverse of Q. In this truth table, J is equal to 0 and K is equal to 0, the output remains unchanged. And J is equal to 0 and K is equal to 1, the flip-flop resets to 0. And if J is equal to 1 and K is equal to 0, the flip-flop sets the output to 1. If J is equal to 1 and K is equal to 1, the output toggles, that is, it switches between the 0 and 1. So the edge triggered behavior is that most JK flip-flops are edge triggered. This ensures that the output only change state when the clock transition, providing more controlling time behavior. So here, coming back to the program, inputs are J, K, C, that is clock and reset. Output is Q and QB, and register Q and QB always at positive edge of the clock. We will begin the program here if reset of Q is less than or equal to 0, and we'll begin case JK. That is, if both the input are 0, Q is set to Q. If the inputs are 0 and 1, Q value is set to 0. And if it is 1 and 0, and it is 1, and if it is 1 and 1, it is the toggle output. So this will be the output of JK flip-flop. If J value is 0, K value is 0, clock is 0, and reset set to 1, Q will be X and QB will be X. So this is the output. Now coming back to the SR flip-flop. An SR flip-flop is a basic sequential circuit used to store a single bit of data. It has two inputs, S and R. So, and two outputs, that is Q and QB or Q0. The flip-flop maintains its output state based on the input combination and the previous state. So coming back to the truth table. So here, so this is the truth table of SR flip-flop. So inputs are S and R, and we will have a clock, and the outputs are Q and Q0. The S input is connected to one NOR gate, and the R input is connected to the other NOR gate. The output of the first NOR gate feedbacks into the second NOR gate. The output of the second NOR gate, that is NOR gate, is the Q bar, feeds back into the first NOR gate. The outputs Q and Q bar are always complements of each other except the invalid condition. That is, invalid condition is if both the inputs are 1. That is, it cannot be 1. So if S equals to 0 and R equals to 0, that is called as the hold state, the outputs Q and Q bar remain in their previous states. If S is equal to 1 and R is equal to 0, the output Q is set to 1 and Q bar becomes 0. If S is equal to R, and if S is equal to 0 and R is equal to 1, that is called as reset state, the output Q is reset to 0 and Q bar becomes 1. If S is equal to 1 and R is equal to 1, this is the invalid state. So coming back to the output of this SR flip-flop, so this is the output of SR flip-flop where S is 0, R is 0, clock is set to 0 and reset is set to 1, and Q value is X and Q bar value is X.